Number 33, justify the last two steps of this proof. So we already know that RS is congruent to UT and RT is congruent to US by the given information. So how do we know that ST is congruent to TS? Well, it's a shared side, so that's always the reflexive property. And last but not least, how do we finally know that these two triangles are congruent? By the side-side-side postulate. Alrighty, 34. Which pair of triangles is congruent by angle side angle? So we're looking for two corresponding congruent angles and the included side, meaning the side directly between them. So if we look at A, this triangle looks perfectly fine, but does the second triangle match up? No, unfortunately, that is not the included side, so those are not congruent. B, this is side angle side in these pictures, so yes, they're congruent, but not by angle side angle. Same reasoning for C. Those are also side angle side, but not what we're looking for. Letter D is angle side angle. We have both angles and the included side. Number 35, what is the value of X? Looking at this picture, seeing that both of these side measures are marked 21, I know that this is an isosceles triangle, which also tells me that these base angles are congruent. So if I already have 38 degrees used up of 180 degrees in my entire triangle, that leaves me with 142 degrees left. Since I know they're congruent, I can cut this measure in half to get 71 degrees each. Number 36. While my class didn't do flow proofs, I'm hoping that you could notice that it's really the same thing as our two column, just it looks a little different. So how do I know they're right angles? It's given. How do I know that BA is congruent to BC? Well, I have these two angles congruent, which makes this, again, an isosceles triangle, which would tell me that those measures are also congruent. How do I know that DB is congruent to DB? It's a shared side. It's congruent to itself, so that's the reflexive property. And finally, how do I know that triangle ADB is congruent to CDB? So I wrote angle, angle, side. Do we have other options? We could also use, because these are a right triangle, I could say hypotenuse leg. So either of those would be valid answers. 37. Points B, D, and F are midpoints for the sides of triangle ACE. So I filled in our information. Again, this should note that FD is a mid-segment for AC. So these are parallel, and I know that this length AC is double the length of FD, so 34. Number 38. Which statement is not necessarily true? So the given information tells me that DE is the perpendicular bisector of JL. So that means what I would say is that the line DE is doing the cutting. It's not being cut. So make sure that you have the right segments marked congruent. So while B, C, and D are all true statements from this given information, I don't necessarily know whether DK is congruent to KE. Maybe it is, maybe it's not. Number 39. DF bisects angle EDG. Find the value of X. I know that when I have an angle bisector, any point along that angle bisector is equidistant from those sides. So those two measurements are congruent. So when I set them equal to each other, I get X equals 19. Number 40. Which diagram shows point P and equal distant from points A, B, and C? So this is just like the problem where we had the three friends coming from the three different gates. If I want a point that's equidistant from each of the vertices A, B, and C, A is the correct answer because this is the meeting place of all three perpendicular bisectors. Number 41. In triangle ACE, G is the centroid. BE is 18, find BG and EG. So we know that with the centroid, we have a piece that's 2/3 and a piece that's 1/3. A piece that's 2/3 and 1/3, 2/3 and 1/3. So I made this lovely little table here. So I know that BE is the entire piece, my entire segment, and that's 18. EG is going to be the part that's 2/3. BG will be 1/3. So 18 divided by 3 is 6. And so if I need 2/3, that would be 12. So EG is 12, BG is 6. Number 42. Name the smallest angle of triangle ABC. I know that my smallest side is across from the smallest angle, so angle B. List the sides in order from shortest to longest. So if this is my smallest angle, that means this is my shortest side, so LK. My next smallest angle is 71, which means that JL will be next. And last but not least, if 76 is the biggest angle, JK is the biggest side. Make those segments. Number 44, which 3 lengths cannot be the lengths of the sides of a triangle? So we're always making sure that if we take the sum of any 2 numbers, it's always going to be greater than the third. So the trick is to look for your smallest 2 and make sure their sum is greater than the others. So 17 plus 14 is larger than 23. 11 plus 11 is greater than 12. 5 plus 7 is greater than 8. Here's the problem. 6 plus 10 is not greater than 21. So these measures would not make a triangle.